what's up guys? Alright, chapter 5. Okay, so previously about periodic table, you learn a few important things that you're going to use in this particular chapter. Okay, octet arrangement, okay, octet stability, and then group 1 releases electron, group 17 accepts electron, which group will form positive ion, which group will form negative ion. Alright, so basically all those will be used in this particular chapter, chemical bonds. Okay, now in here, in this chapter, you're going to learn, I think, around 4 to 5 chemical bonds. Okay, previously, if according to KSSM, they're only learning 2 types, which is ionic and covalent. But for you guys, which are the KSSM batch, you are going to learn ionic covalent, hydrogen bonds, dative bonds, and metallic bonds. Okay, they have added in 3 new bonds for you to learn, which we learned during Form 6. Okay, so you guys are going slightly more advanced compared to the previous year students. Alright, so I'm not going to waste much time. Okay, bonding. What is a bond? Alright, technically when elements combine, okay, if you combine different elements to produce a compound, okay, how they combine is what we call bonding. Okay, so we have the picture of my salt here, and you know that salt, the chemical formula is sodium chloride, NaCl. Okay, so how does the sodium and chlorine combine to get your sodium chloride? Okay, so basically this is what you guys will learn in this particular chapter. Okay, the way the elements combine is what we call bonding. Alright, alright, so bonding. Okay, so different elements, the way they combine is different. Okay, so that is why you're learning 5 different types of chemical bonding. You have ionic bonds, covalent bonds, so on and so forth. Okay, so we are going to start off with the ionic bonds. Alright, now if you form a compound, you need to remember one very important criteria to form a compound is that it needs to be stable. Okay, now if this one is not stable, so this is actually stable, right? Sodium chloride is stable. Okay, if it's not stable, meaning that they will disintegrate. Disintegrate meaning they will disappear, meaning they will form, you will see for all, then suddenly they will disappear. Alright, so how do what they call elements combine will depend on the octet rule. Okay, the octet or the duplet rule. Okay, so when you form chemical bonds, we need to take into consideration the duplet and octet stability. Okay, if you are stable, meaning that both have already achieved what they call octet stability. Both sodium ions and chloride ions have already achieved octet stability, right? So how do we know all these things? Okay, we're going to go into more detail in your chemical bonding, especially on how to draw. Okay, in this particular chapter, a lot of drawing. You're going to draw circles until you go mad. Alright, basically last year my students, they were drawing until like they were getting nightmares. Okay, but it's very important and it's not very difficult. Alright, so first things, 2 chemical bonds. Actually you have 5, but because this one is from my last year's notes, that's why I missed out the 3 other ones, but never mind. Okay, let me introduce you to 2 first, ionic and covalent bond. Okay, so you have 2 bonds, alright, and then ionic bond I did mention before. Okay, is formed between metal and non-metal. Okay, whereas for covalent bond is formed between non-metals. Okay, so this one is very important. Okay, this is between non-metal. Covalent bond is between non-metals. Ionic bond is between metal and non-metal. Alright, so you need to know in your periodic table which group are metal, which group are non-metal. So the one on the left, group 1, 2, 3, metal. Group 14, 15, and 16. Group 15, 16, 17, non-metal. Okay, so those are the important things. Alright, so normally for ionic bond, so how they form the bonds, meaning how they combine, is that one of it will donate the electron, another one will accept the electron. So it's basically like you not enough money, I give you my money. Okay, that is for ionic bond. Okay, for covalent bond is we share. All right, we want to buy something, both not enough money, we combine our money and then we buy together. Okay, that is for covalent bond. Okay, that's why if you see here the term, this is sharing of valence electron, this one is release or donate. Okay, so for an ionic bond, my dog. All right, so for an ionic bond, one will donate the electron, one will what they call accept the electron. All right, okay, so that is the what they call brief introduction on ionic bonds and covalent bonds. Okay, that is why here you will form ions. Okay, positive ions and also negative ions. Okay, remember positive is called cation, negative is anion. Okay, enough said. Let's go into ionic bonding. Alright, okay, so when we talk about ionic bonds, meaning a bond formed between different ions. Okay, same ions cannot form bonds. Okay, same charges will repel. So it's always different charge. Okay, alright. That's why it's always formed between a cation and a anion. Okay, so they are attracted towards each other by a strong, this is very important, electrostatic force. Okay, you're going to use these keywords in your explanation. Very, very important. Alright, so because of the strong electrostatic force, they will form ionic bond. Alright, meaning the positive ion and the negative ion, they will come together and form the ionic bond. Okay, between which group? Okay, metals and non-metal. Okay, so you need to remember your periodic table, your trend, which are metal, which are non-metal. All right, and then remember I told you before, okay, the metal group, they will always release. Okay, once they release electrons, they become positive ions. All right, and then group 15 until 17, they are going to accept electrons to form negative ions. Okay, so remember all these important properties. All right, so ionic bond, I'm going to show you how how do we explain, okay, the formation of the ionic bond. So here you're going to draw the electron arrangement. Okay, like I mentioned, this chapter involves a lot of drawing. So let's look at the first one, sodium chloride. Okay, first thing we need to do is electron arrangement. Okay, so 2, 8, 1. Alright, my electron arrangement based on the proton number, alright, 2, 8, 1, 11. This is 17. So 2, 8, 7. Okay, so we need to know the formula of the compound form. Of course, you know that sodium and chloride ion, they combine to form sodium chloride. Okay, in chapter 3, we learn about formula, right? For example, like this. And then you say you switch, right? Cross the charges, bring down, and then you get NaCl. Okay, now when it's, let's say for example, magnesium is 2 plus, I hope you still remember your charges. Okay, I did mention that you need to memorize all your charges, right? So you switch your charges, so 2 here, 1 here, so this one will become Mg1Cl2. Okay, so in chapter 3 you already know how to write the chemical formula of a compound when you mix two different ions. Okay, here we're going to go into more detail. We are going to prove, we are going to show how we get this one and this one. Okay, alright, so first let's look at sodium. Alright, sodium, so sodium atom. Okay, we know they are going to release one electron to form sodium ions. Alright, so I'm going to draw this. Oh, slightly off. Never mind, doesn't matter. Okay, Weird shape. Never mind. Alright, sodium. Okay, so 2, 4, 6, 8, and then 1. Okay, 1 valence electron. We know they are going to change into sodium ion. Okay, so how do they change is that they are going to release, okay, 1 electron to form sodium ions. Alright, so alright, that's done. Okay, now once you already release the valence electron, meaning the third shell is already empty. So once the third shell is empty, you don't need to draw out the third shell anymore. Okay, so sodium, then you just fill in the rest. 2, 8, 4, 6, 8. Okay, for ions, we need to draw the bracket. Alright, and then here we are going to write the charge. Okay, so this is how we draw the electron arrangement for ions. Okay, so sodium atom will release 1 electron to become sodium ion. Okay, the reason why they release 1 electron is because they want to achieve stable octet arrangement. Now, for sodium ion, my valence electron is 1. So what we call the idea is like this. Which one will it be easier? Release 1 electron, okay, or to accept 7 electrons to achieve maximum of 8. Alright, so it's basically like if I accept 7 electron, it's going to be more work, whereas releasing 1 electron is less work. That's why it is always easier for the metals, okay, group 1, group 2, and group 13 to release the electron because it's easier. Because once they release the electrons, okay, the second shell will become the outermost shell. You see, third shell already empty, right? So second shell will become the outermost shell, so already achieved maximum 8 electrons, stable electron arrangement. Okay, so that is why sodium ions, they are going to release electron. So when you draw the what we call electron arrangement for ion, okay, remember you need to put in the bracket, close the bracket, and then put in the charge. Okay, charge will depend on how many electrons release. Release 1 electron, positive. Release 2 electrons, 2 positive, like that. Okay, alright, so if we compare the electron arrangement here, this is 2, 8, 1. Okay, but for sodium ion, since I did remove 1 electron, right, the electron arrangement will become 2, 8. Okay, so this is very important. Alright, in the exam they will ask you, maybe in the objective they like to ask what is the electron arrangement for sodium ion. Okay, so this is the electron arrangement. So if I were to put it in sentence, okay, we are going to say that sodium atom releases 1 electron to achieve stable octet stability, to achieve stable octet electron arrangement. Okay, so they become sodium ion. Alright, okay, next we are going to look at chlorine. Okay, so I'm going to draw here chlorine. Alright, chlorine. Okay, so chlorine atom. Oh, alright, chlorine atom. So electron arrangement 287, right? So circle. Okay, draw nicely. Alright, chlorine. Okay, so you have 2, oops. Okay, 8, then 7, 2, 3, 4, 6, 7. Okay, now in the case of chlorine, okay, they are going to form chloride ions, Cl negative. Okay, they are going to form chloride ions by accepting 1 electron. Okay, so technically, chlorine atom, they are going to accept 1 electron to achieve stable octet electron arrangement. So, oh my gosh. Oh, okay. Oh my god. Okay, so 2, 4, 6, 8, 2, 4, 6, okay, 7, and then they are going to accept 1 electron. Okay, so once they accept 1 electron, you can see that now their outermost shell already achieved maximum 8 electrons, okay, meaning already achieved stable octet electron arrangement. So if I accept 1 electron, my charge is going to be 1 negative. If I accept 2 electrons, then here will become 2 negative. Okay, so let us look at the electron arrangement here. This is 2, 8, 7, whereas this one, since I already accept 1 electron, right, so it becomes 2, 8, 8. Okay, so now I'm going to combine these two things. Alright, I'm showing you step by step. So now I'm going to combine these two things to show you how you get your sodium chloride. Okay, more or less you already know, but I'm just showing you. Okay, so the electrons released by the sodium, sodium will donate their electrons and give it to chlorine. Okay, and then by doing so, they are going to form ions, and then they are going to attract with each other because of strong electrostatic force, and then to form the ionic bond. Blah 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 blah. All right, so how we draw, I'm going to show you the step by step. So sodium atom. Okay, oh my god. All right. Okay. I'm going to use red sodium. 2, 4, 6, 8. Okay, 1. All right. Okay, and then you have chlorine. Okay, plus chlorine. Okay, chlorine. 2. Oh, slightly off. Never mind. Okay. Ugh. Alright. I'm going to use a green. Okay, different color so you can see more clearly. Okay. Don't worry. By the time you finish this chapter, you are going to have nightmares drawing all these things, which is a good thing. Alright, 2, 8, 7. Okay. So, this is sodium atom. This is chlorine atom. Alright. So what will happen is that the sodium atom, right here, they are going to donate their valence electron to the chlorine. Okay, since chlorine only need one more, right? So the sodium, the electrons released by the sodium will be given to the chlorine. And then you are going to get your, what do you call, sodium chloride, your ionic compound. Okay, so sodium, then, oops, 1, 2, then for chlorine, 2, 3. Okay, doesn't matter. Sodium chlorine. Alright. So 2 electrons. 1, 2, 3, 4, 6, 7, 8. Okay. So bracket and then the charge. Okay. Now for your chlorine, you're also going to do the same thing. Alright. Oops. Okay, so here 1, 2. Okay, it's a hassle drawing all these things. Blah, 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 blah. Ugh. Alright, 7. Okay, and then the another electron comes from the sodium. So I use red. Then you can see very clearly. Alright, again, bracket, and then charge. So this is the electron arrangement for sodium chloride. That is how you draw the electron arrangement for a compound. Okay, this is for a single ion. Okay, so technically what you are doing is you're combining the two different ions together. Alright, so after you draw it like this one becomes this one becomes this one, and then you combine the two ions together. Okay, so we say that both ions has already achieved stable octet electron arrangement. Okay, and then they are being what you call attract towards each other by strong electrostatic force. Okay, because of different charges. All right, so that is how you draw the electron arrangement for a compound. Okay, sodium chloride. Yay! First part done. Okay, now this is the explanation. Okay, normally they will ask you to draw and explain. Okay, because I mentioned here explain formation of ionic bonds. Alright, so we always start off with the electron arrangement. So this is 2, 8, 1. Okay, and then they have one valence electron, sodium. So not stable. Okay, because they haven't achieved octet. Alright, so to achieve octet, they are going to release one electron to achieve stable octet electron arrangement. Okay, you must have this in your answer to form sodium ion. Okay, sodium ion Na plus with electron arrangement 2 8 2 8 only. Okay, so sodium. Okay, when you explain, you need to explain for formation of both ions first. So sodium becomes sodium ions, and then chlorine becomes chloride ions. Okay, so you see the next part, we are going to talk about chlorine. So electron arrangement is 2 8 7. Okay, so they have 7 valence electrons. So they are going to receive 1 electron to achieve stable octet electron arrangement to form chloride ion. Remember, your negative ions, the name is different from the atom. This is chlorine atom, this is chloride. Okay, with electron arrangement 2 8 8. Okay, therefore your sodium ions and chloride ion, alright, chloride ions are attracted not with by strong electrostatic force. This one must have in your answer. Okay, so the bond form is called ionic bond. Alright, but basically that is how we normally explain. Okay, you need to explain the formation of the positive ion. Next, you explain the formation of the negative ion, and then this one you must always write this. The two ions are attracted by strong electrostatic force. Okay, normally a lot of students, they always forget to write out this one. Okay, so the key points that you must have in your answer: achieve stable electron arrangement, and then electrostatic force, strong electrostatic force must have in your answer. Okay, when you explain the formation of ionic bonds. Alright, so that's it for sodium chloride. Ta-da! Okay, so let me show you, for example, magnesium oxide. Alright, so this is 2 8 2, whereas oxygen is 2 6. Okay, so based on the electron arrangement, you can actually guess the formula or how much electrons they are going to need. Alright, basically magnesium, they are going to release the 2 electrons. So the 2 electrons will be donated to the oxygen. So once the oxygen gets the 2 electrons, they are going to achieve stable octet electron arrangement. Okay, so I'm not going to go into too detail. I'm just going to show you the simplified version. Alright, so magnesium 2 8. Okay, magnesium, oh my god, Mg. Alright, and then plus 2 6. Okay, this is oxygen. Alright, magnesium. Just now we start the drawing part. 2. Okay. Alright, so let's say like this. Okay, and oxygen. 2, 4, 6. Okay, so magnesium, they are going to donate 2 of their electrons to the oxygen. Alright, so this is Mg atom, this is oxygen atom. Okay, so once they donate, okay, so remove 2 electrons, third shell no more. Right, so your magnesium, oh, okay, like this one, away. Okay, and then oxygen. So 2, 2, 4, 6, 8. Okay, remove 2 electrons, remember, bracket, and then the charge. 2 electrons, so 2 plus. Alright, and then oxygen. Okay. Okay, since they accept 2 electrons from the magnesium, right? Something like this. Alright. Okay, maybe too near. Okay. Oops daisy, same mistake again. Alright, so close bracket. Accept 2 electrons. So here is 2 negative. Okay, so this is the electronic arrangement for magnesium oxide. Okay, remember in chapter 3, Mg2 plus and then O2 negative, right? You cross. Since they have the same, this one simplify, that's why you get MgO, right? So this is how you draw the electron arrangement for this one. Okay, magnesium oxide. Okay, so for ionic bonds, it's actually not very difficult. Alright, for ionic bonds, normally it's very straightforward and very obvious. Okay, you know the element is going to donate how much and then going to accept how much. Okay, how we know is based on the electron arrangement. So remember, because we need to achieve octet, right? So you just need to figure out how to make sure that this one becomes 8. Okay, this one accepts 6, more work. Throw away the 2 straight away becomes 8, so it's easier. Alright, that's why they will release the 2 electrons. Okay, so this one normally I write donate. Okay, so that is how we draw the electron arrangement for the compound. Okay, remember this is compound. These 2 are elements, right? Magnesium atom and oxygen atom. How they combine is by one donates, the other one accepts to form the compound. Okay, so the explanation here is actually the same as above, just that you change with different stuff, right? Okay, here is 2 valence electron. Okay, so on and so forth. Okay, so that is it for the ionic bonds. Okay, that is enough. Alright, so today you already learned how to draw the electron arrangement for ionic bonds. Okay, just remember, must always put the bracket when they change into ions. Okay, and then the charge must be there. This one is what we always check when we mark your exam papers. Alright, whether you have the bracket and the correct charge here. Next thing we will check is whether your electron arrangement here is correct. Alright, so the moment we see that the charge is wrong, we are not going to look at it anymore. Immediately it's wrong. Straight away we know. Okay, so that is it for today, your ionic bonds. Okay, next we are going to go into covalent. Alright, see you next time. Bye.